Hey everybody, welcome back to another video. So today we're going to be doing a little bit of review for the chemistry test tomorrow. I know it's super late, but yeah. All right, so let's go ahead and get started. I'm pulling these problems right off of our study guide, so I would take a look at that. But here's just a step-by-step process to help anyone who is struggling. All right, so the word equations are probably going to be the harder ones, but honestly, considering we know how to name, it's pretty simple. So remember, when we're naming, you just have to follow the rules of ionic naming and covalent naming. So I would recommend having your polyatomic ions chart for the test and write notes on that. So yeah, okay. So let's go ahead and name. So lithium chloride. Lithium has a 1 charge, I think. I don't exactly remember, but I believe it's LiCl, which would be lithium chloride, plus Cu, because copper 2 bromide. Copper 2 bromide. Copper has a 2 charge, bromine has a 1, so CuBr2. That is our reactants. Okay, now let's name our products. Okay, so let's go ahead and take a look. Lithium bromide, that's just LiBr. And then copper 2 chloride, which I forgot to write, but the equation wouldn't work properly if it was just copper chloride. So copper 2 chloride. So remember, CuCl, but there's a 2 because copper has a 2 charge. Okay, so now we have the naming. And now it's just simple balancing. So let's get our chart set up. LiCl, CuBr, LiCl, CuBr. Okay, so let's go ahead and take a look and make sure or count out all of our atoms. So we got 1 lithium, 1 chlorine, 1 copper, and 2 bromine. And then over here, 1 lithium, 1 bromine, 1 copper, 2 chlorine. All right, so we already have a problem. So let's go ahead and just put a 2 here to match up to have 2 chlorines. So now we have 2 lithium, but we also have 2 chlorine, and we still have that. So we have 2 of everything except for copper. So now on this side, we have an issue. So we have only 1 of lithium and 1 of bromine, but we need 2. Okay, so let's just put a 2 here, and then 2 lithium, 2 chlorine, 1 copper, 2 bromine. And there you go. That is our balanced equation from our word equation. Okay, let's do another example of a word equation to our regular compounds and then to balancing it. Okay, so let's take a look. Phosphoric acid. Remember, this is just about naming. So just remember how to name your acids, your ionic compounds, and your covalent compounds. So phosphoric acid is simply H3PO4 because that is our phosphate. I believe it's phosphate. Yes, phosphate. Anyways, and then because it has a 3 charge, it goes to the hydrogen. Plus sodium hydroxide, which is just NaOH. That turns into H2O and sodium phosphate, which is Na3PO4, because remember with our phosphate, it is a 3 charge. So that goes there. All right, so now what we're gonna do is we're gonna set up our chart, or you don't have to if you don't want to. This is just the way that I do it to ensure that I'm doing things right, because otherwise I'm just gonna be a hot mess. PO4, and remember, if you have the same polyatomic ion on each side, you can keep the same. So keep your PO4 the same just to make it easier on yourself. And then do an And then do your OH. So keep your hydroxide together. And so on this side, you might be wondering, well, there's no hydroxide on this side. Actually, there is. So if you break apart your H2O, it just becomes HOH. So you have hydrogen with a hydroxide atom. So let's set up this over here. And then we'll get that together. Okay. So there's 3 hydrogen, 1 phosphate, 1 sodium, and 1 OH. If I said nitrogen, which I may have, I don't remember. That is not nitrogen, that is sodium. I just cannot speak English clearly. Okay, so because we're separating the OH out, we're just gonna have 1 hydrogen. We're gonna have 1 PO4, 3 sodium, and 1 OH. Okay, so there's currently 3 hydrogen and 3 sodium, which is kind of messed up. But remember, we want to save our hydrogen for our second to last, so let's not do that. So let's go ahead and put a 3 here and for the NaOH. Okay, so let's go ahead and do that. All right, and so NaOH, so that becomes 3, that becomes 3, 3, and 1. Okay, so now our OH is messed up. So we have to balance that. So let's put a 3 in front of here. There's now 3 OH, 3 hydrogen, 3 sodium, and still 1 phosphate. So now we have a balanced equation again. So if we look at that, that was so easy. That was so easy. And so, yeah, that is a completely balanced equation for phosphoric acid reacting with sodium hydroxide to produce water and sodium phosphate. Now let's take a look at another equation, but this time the compounds are already out. You don't have to name anything, so that makes your life a ton easier. So let's go ahead and start with setting up our chart. So let's put our zinc, our fluorine, I don't know, and our iron. And then do the same thing over here. Zinc, fluorine, and our iron. Okay, let's go ahead and start counting. So there's 1 zinc, 2 fluorine, and 1 iron. There's 1 zinc, 3 fluorine, and 1 iron. So we can already see there's a disparity in our fluorine. So let's go ahead and fix that. And so a little bit of math here. Think about a common factor between 3 and 2. It'd be 6. So to make that, to match up our fluorine, I'm going to add 2 here. That's what I'm going to do. And then I'm going to have 2 iron. And then I'm going to have 6 the fluorine. Our zinc is going to stay the same. And then I'm going to match that on the other side. And so I'm going to put a 3 in front of our zinc, fluorine 2. And then I'm going to end up with 3 zinc. I'm going to end up with 6 fluorine and 1 iron. Okay, so that's that. Now our fluorine is balanced, but there's some disparities in our zinc and our iron. So to fix that, let's just put a 2 in front of our iron on this side. So 3, 6, 2. And then to fix the disparity in zinc, just put a 3 in front of the zinc. So 3, 6, 2. Perfect. Now we have yet another balanced equation. Okay, here's our final example. All right, so let's go ahead and look at this. This is already, like, the compounds are already named, so we do not have to worry about naming. So let's go ahead and set up our charts. Or don't. It doesn't really matter. This is just the way that I do it. And I know for a lot of people it helps to visualize, so that's what I do. So because we see carbon, hydrogen, and oxygen, we know this is a combustion equation, which is the most difficult to balance. But you know what? It's okay. We're going to get through it. Okay, so you know the deal by now. I'm just going to count out my atoms. So there's 6 carbon, 12 hydrogen, and 2 oxygen on this side. And on this side, there's 1 carbon, there is 2 hydrogen, and there's 3 oxygen because there's 2 here and there's 1 here. Okay, so pretty much everything in this equation is completely messed up. But remember, we want to do hydrogen second to last and oxygen very last. And remember, that is because typically in our equations, especially combustion equations, our oxygen is going to be in itself as a diatomic. Remember, Brinkelhoff. Write it down on your periodic tables for the test, I beg of you. Okay, so now let's go ahead and match our carbon. So I'm just going to put a 6 here because that will help to balance that. So remember, we're going to balance our carbon first. So we have now 6 carbon, and I have, if I can do math, which is very unlikely, 13 oxygen, and our hydrogen doesn't change. Okay, so now that's balanced. That's balanced, but our hydrogen, not so much, because there's 12 over here, right? So let's go ahead and use our big brains and think, oh, 6 times 2 is 12. So now let's do that again. There's no change to carbon. Now there's 12 hydrogen, and there is 18 oxygen? Yes, 18 oxygen. Okay, so now our carbon and our hydrogen is matched, but what about our oxygen? That's when our diatomic oxygen comes into use. So 18 divided by 2 is 9. So let's just put a 9 here. Then there's 6 carbon, 12 hydrogen, and 18 oxygen. Look at that. We balanced that combustion equation so quickly just by remembering some simple rules. And honestly, I would recommend writing rules that would help you on the test down in your periodic table, because she allows us to write notes on our periodic tables. It's such a helpful resource, and it'll help you do this as quickly as possible. So I really hope you guys enjoyed this video. If you guys have any questions, feel free to reach out, and yeah, have a great day, everyone.